Hi. I'm part of the Echo Robots race team. And I'd like to present to you the Echo RV, a completely automated, state machine controlled robotic vehicle. So, what does our project do? The aim of our project was to educate sixth form students about state machine diagrams. Our project uses state machines in order to control all the outputs on the DE2 board. That includes motors on the robot, as well as all the hex displays and the LCDs. Inputs such as time and switches can be used to switch between the transitions. Echo Grand Prix. Echo Grand Prix is a fun and interactive application of state machine diagrams. Students can create their own race course and use state machine diagrams to navigate it. The front end. The front end is an easy way to create state machine diagrams. The ease of use means students can get right down to creating state machine diagrams without having to learn a complex piece of software. The screenshot shows the state properties. We can use these to display the state name on the LCD displays. We can also specify transitions between the states. Also, we can do save and load, which allows us to make more complex projects. This shows an actual state diagram of something that you might do in a race. State machine diagrams can be of any size and can include any length input expressions. State machine compiler, the engine of the robotic vehicle. The compiler was one of the most challenging aspects of the project. It took the state machine diagram structure and compiled it down to MIPS assembly code. We chose to use the load of tools provided as part of the ECAD labs and also the MIPS soft core. Using a stack-based recursive implementation, we can implement really, really big input expressions or really small ones. The software simulator. This allowed students to learn a little bit more about assembly code by viewing the effects and stepping through and seeing the effects on memory. It gives an extra level of complexity for the more interested student. The robot itself. So, this is our robot. We can see that it's got two motors on the left and right side, which allows it to drive forwards, backwards, and turn on the spot. It's also got a touch sensor on the front and back, which allows it to interact with its environment. Finally, we implemented it so that it can run from batteries, allowing the robot to run free. Challenges and lessons learned. So, spanner in the works. The tools provided don't actually combine, so we had to collaborate with the designers of the MIPS software in order to get this to work. The compiler stack implementation also proved to be a problem since the stack and frame pointers don't work either. So we implemented it using different registers. Lessons learned. If something in hardware has a slight risk of breaking, it will break. Don't take apart the robot half an hour before the client meeting, particularly if you can't remember how to put it back together again. Always spend more time than you think on planning. Plug sockets are live.